Okay. First of all, why would someone snapping photos of a plane, right? Uh, so because it's fun. I have a friend that he likes to take a photos of a maybe train or planes, because it's fun. And this project, the input, I took the input from the Open Sky API. Yeah, you guys can access it from this link. And the output is the bearing angle and the elevation angle. So I will explain that later. But so pros and the pros and cons of using API would be it's cheaper, it's free, and it's much simpler than using the SDR. But it's so much slower and limited data. So as you guys can see, it's faster, more accurate data because it's took from the real time because ADSB. So you can took the ADSB using SDR. Uh, of course, you guys have unlimited request calls because you don't use API. But the cons is it's too expensive and complicated. So what is it compass pairing? So as you guys can see, compass pairing is an angle of the plane that angle from the north, right? Like you guys, if you're standing right here, it's not the angle that you point vertical, but it's horizontal. And it's relative to the north, right? So we count it from the north. And this is the formula, and you guys don't have to know this because I don't know. And this is the code from the compass pairing. So we took the latitude. Latitude 1 is our POV. Latitude 2 is for the airplane, and the longitude 1 is our POV, the camera, and the longitude 2 is the plane. So you guys can see the code right here just for the compass bearing. So this one is elevation angle. What is an elevation angle? So elevation angle is it's different from before compass bearing, right? If compass bearing is horizontal and the right and left movement, but elevation angle is the up and down movement. We took the angle from the bottom to the up, right? This is the formula for it. You guys can see. So basically, this calculation use trigonometry. So this is a nightmare. This one. This is the elevation formula. So for the elevation one, you need to know the distance of you and the plane using the Haversine formula. So this is the code. So you have to calculate the distance between you and the plane using the Haversine. This is the left one is the Haversine, and the right one is you calculating the elevation angle. So this is how you retrieve data from the OpenSky API, but I cannot show you guys how to do it right now because the servers of the OpenSky is, I think the request is too high, and I think it's down right now. So this is the device. So we use two zeros for the compass bearing and the elevation angle. So this one, you guys can use any camera. For this project, I use 64 megapixel Arduino cam, Ardu cam, but it's not for Arduino, of course. And the bottom one is the Raspberry Pi 2. So we'll have the rest for the question. The rest of time, do you guys have a question? For this one? Or should I explain more about this one? About the. Okay. Actually, no, because I can't use the API right now. The picture of the planes that I took from it. Ah. So I don't have it right now. But you guys will have it on my GitHub. I will update it soon. Okay. So, got so much time.
I have a question though.
Okay.
Is the OpenSky API has much data that is like similar to the ones that are available from, let's say, Flight Radar 24?
No, because if you use OpenSky API, so it's
Like it has limited data compared to the
yes,
commercial one.
it's only pick up the data from the SDR that someone contribute to the network. So if you have an SDR, right, so that pick up the ADSP signal, you can contribute to the network. So it's very limited data. The coverage is not 100% global. And even it has some API limit rate calls, right? So it's very slow. I don't recommend it to use it for this project.
What's the API rate limit for that?
Ah, this is a good question. It's one request per 10 second. So it's very slow, right? If you use your own SDR, it will be very fast, right? In the real time, it's very good. So consider using an SDR.
What are the other APIs that we can also consider using for this project, like our other technologies you've considered when you're building?
Recommend paid services that would be good also, paid or free.
So the paid one is the Flight Router 2024, right? It has an API. Yeah, but still the request call is very slow. It's that one is 6 seconds. 6 seconds. Very slow. But you guys can use like predictive models, right? So you guys know the track. So you predict the planes before it took there. So you can counteract the slow limit. I would recommend you guys using the ADSP signal. So it's because it's real time.
So you have to buy an equipment to receive ADSP.
Yes. So I would recommend you guys to use angle servo 2. You guys don't use the 361. So use the 181. Because the 361 is continuous servo. You can't control the degree, only the speed of it.
Do we have any more questions?
Okay, I have a question, right? So you explained to us compass bearing, right? And or you explained to us what we get from the API, right? Which is a bunch of numbers, basically. My question is, um, I'm very interested in this project. So I'm interested as to what do we actually use the data for in this whole project, right? So, like, do we use the numbers for um, predicting when we should take a photo, for example, like that, or what?
I will show you this all states from the Open Sky network. Wait. Why is not so? Huh? Hello. Why is not showing? Right there. So the data is like this from the Open Sky network, but this one is offline. It's not updated. So you guys will get the latitude and the longitude, right? And the altitude. So the positional data from the airplanes we took. So and then we process it that we can get the compass bearing and the angle, elevation angle, so we can point to the airplanes. So we can snap it with the camera. But I recommend to use the better camera and the telephoto lenses. So as you can see, this one doesn't have one, only the camera, not the telephoto lenses. So does this answer your question? Okay. Maybe we should work together for this project. I think it's very time consuming.
Do we have any more questions? Thanks for showing the device because that's related to what I'm going to ask. So you are using this device, right? And it's supposed to, given the elevation angle and the compass bearing, it's supposed to get all of those angles, right? Uh, what do you do if in case the plane or the device is set on an angled plane, right? Like for example, if you're just going to put it on a table, of course going to get a 90-degree for elevation angle and the compass bearing, right? But if, for example, you wanna place it outside, but there's no plane or horizontal plane for you to put that really has a straight horizontal angle. Did you have anything to handle that one? Like for example, a gyroscope or something, just to make sure that there's really 90% 19-degree or the straight line, I say, on horizontal line.
So that's very good. I think it's not a question, but it's very good point. So this one doesn't have a gyroscope to counteract the, what do you mean? If you don't have any straight plane like a table, so you can't use this. So it does have to place that in a straight plane right there. So it will be good if you add a gyroscope to the servo itself, to the camera itself. So it will target the target angle, right? So even if you move it in your hands, it would be stable. If you add the gyro in the camera itself. So not in the bottom, right? Not in the bottom, but in the moving parts. It will be very good and more accurate.